So next we're going to have Dr. Yuri from Texas A&M University. So Yuri is an assistant professor and extension specialist in ag economics at Texas A&M University. His research focuses on applied decision support tools, digital agriculture, and risk management, combining econometrics, artificial intelligence, and cloud-based technologies in doing his research. So Yuri has a PhD in managerial economics and agribusiness, and has over a decade of experience in academic and policy-oriented research. He has held visiting positions at the University of Chicago, University of Manitoba, and University of Illinois. Dr. Cali is also active in international collaboration and has worked with institutions in Brazil and across the US. His outreach efforts supports producers in South Texas with tools that improve farm profitability and resilience through data-driven decision-making. So Yuri is going to be presenting on Cotton Analysis app, which is an interactive web application for the cotton markets in the United States. So I'll hand it over to Dr. Khalil now.
Hello there. Good morning. First of all, I would like to kind of make a gossip. We just attended the AEA, and I heard really good feedback about IFAMA. People who attend in Ribeirão Preto said that they love it. It was a great conference. They love the food. They love the city. So we know it's really hard to organize. I would just like to say that kind of feedback. So anyways, let me move forward. Well, my talk today is going to be about a web app for analyzing and forecasting cotton market data. But this is a paper or a project under a big other effort that we have about digital agriculture. And I'm going to mention a little bit about this to give a context, and then I'm going to go down and talk about how this web app fits in this big effort. Although I'm presenting, Abidinardo Oliveira developed this web app while he was visiting scholar or postdoc here with us, and also have the collaborations of Juan Landivard and Luis Ribera, and among others in this big project. Let me see. Oops. So I'm going to talk about why this would be relevant in the context of digital agriculture. I'm going to talk a little bit about our digital twin models and how all of this fits and what would be the implications of digital twin and how we take advantage of the web app. And also then I'm going to do some conclusions about it. First thing, or one of my argument is that digital agriculture enhances productivity and facilitates risk mitigation and potentially reduces costs. And digital agriculture can help a lot the farmers on these fronts. And mainly, I would emphasize mitigate risk as well, because that would be relevant for the producers. So how we can improve productivity and what makes the productivity or improve productivity or grow is technology. So if we adopt technology, we have more productivity overall. That's the idea. But agriculture has some features. For example, we have no environment control. In other words, the crops out there in the environment. We have the biological time. For example, when the plant grows, we try to develop things, but that's what's happened. And if we use digital agriculture, we can kind of mitigate these risks. And if you guys can realize, almost all the development in agriculture technology trying to reduce the biological time or somehow control the environment. So the first big solution regarding technology was like the Green Revolution, and the Green Revolution brought like a standardized management practice. The same receipt for everybody, you adopt this and go ahead. And that revolutionized agriculture and end up gave a Nobel Peace Prize for Burlock. However, nowadays, the more advanced part goes towards the digital agriculture. And digital agriculture brings a tailored management at finer scales. We customize more and more. Instead of like a standard thing, we tailor for a specific farm, for a specific field, for a specific plant, and so on and so forth. In this road, we end up developing one thing we call, the literature call digital twin. So the digital revolution encompasses all these things that we are using: robots, drones, 3D printing, AI, blockchain, Internet of the Things, and so on and so forth. And all of that is part of this big, big project. So what is the digital twin? Digital twin ends up being like a digital representation of the crop, the physical crop. So digital twin is a data-driven replica. Is update all the informations from the field in real time, and we use simulations to make decisions. So as a result of the digital twin model, we have two main things: predictive analytics and prescriptive analytics. So we set up the field, we collect the data, we update our database, and as a result, we have more and more forecast. And as we see the forecast, we try to simulate what we do something in the field. If we change, what would be the results, so we can have a prescriptive analytics out of that as well. So just to give an example, for cotton, that's the crop that we are talking about. We fly the drones, we collect data like canopy cover, height, volume, excess of greenness, and so on and so forth. And all this data are going to allow us to follow the crop in real time throughout the time. And we forecast the yield. So once we forecast the yield, we're going to understand with the historical data and with growth patterns how the yield's going to look like. And we have a bunch of interventions that we learn through time, and then we can do like in-season crop management. That would be kind of the idea. So we do in-season crop management since once we have like the prescriptive analytics. Just for you guys have an idea, this is a cotton fields through time. So since planting until harvest, we follow that. We fly the drones. We have satellite data, and for each one of these squares or grids, we're gonna know exactly what's the growth pattern and what we can do to optimize whatever we want. So that's the overall idea. And we have a model that's a kind of really big. We collect data, big data, we cluster the model, we have a library of models, because we have a model for each grid, for example. And then we combine these models, we do hybrid models as well, and then we forecast. And then we have yield predictions. But beyond all of that, my point today will be more about price forecast and economic decisions once we have all of this technology in place. So just to emphasize, we go in one farm and we collect data and we fly drones and we have satellite data as well. We have been doing this for over 5 years, so we have a bunch of data. Also, we go and have satellite data and also drone data, and all of that comes together, and we have our grids in the fields, and we can have a distribution growth patterns for each one of these grids. So, and then once we collect all this data, we use the best model, and most of the times end up being like Bayesian neural networks, and we predict the yield. So, but we've been really successful in predicting the yield, and that is Pankaj Paul and Liu, this other postdocs that has amazing work. So we can predict the yield like in about 6 weeks before harvest with over 99% of accuracy. So the models work really good in predicting yield that help farmers make a decision. So the next question comes, hey, we can predict the yield very well, but what would be the implications for that? So if you can predict yield very well, we have overall, when we talk about like the overall economy, we have investment attraction, we can talk about credit, we can talk about insurance, we can have like coordinate supply chain, we have better government planning, we can have like think more about food security, because we can predict how much yield or how much product we will have in the future. And that's also mitigate the risk and give advance for people to plan. But my point today is kind of deep down inside the farm. So here is a simple way to look at the profit of the farm during one crop season. We have the random profit as explaining by one random revenue. That's random price, random spot prices, random yields, and how much the guy planted, the acreage, minus the production cost, and he can do some strategy in the future markets. So we have future price, settle price, and you have the how much contracts he gonna buy to do hedge or not. Notice that all this tilde on top means like random variables. So you see that when we predict the yield really good, this is why we kind of mitigate or reduce the risk regarding yield, which brings more previsibility for our forecast or for the profit management part. So we have price basis and production risk, and basically we mitigate the production risk with this part, and we left over price and basis. So we try to tackle that. What I said, we go after the production risk. Now we're gonna go after basis and price risk. So first thing that we can do with this technology is in-season crop management. This helps reduce our costs. So we do like irrigation scheduling, fertilizer management, pest and disease control, and growth monitoring and harvest management. All of that help us because we can predict the yield and we can observe the patterns. We can intervene, and we can even know exactly when we're gonna harvest, and that brings a lot of advantages. In Texas, water is scarce. So with our technology, for example, we can maintain the same yield, for example, and reduce 20% of use of water with a little bit smart. So all of this thing is really relevant for the producers. Another kind of thing that we do that can bring some management insights is this profitability index. For example, for each grid, every day, every week, we can know how much money he's making or how much revenue he are making for each one of the grids. First thing to notice here is that in some areas in this field, the producer make money in these green lights. In some areas, he's losing money. So when he got like the data from the whole field, he does not know that some green areas is subsidizing the red or the orange areas. And our question is, what can we do to change that? And then you can see that in some places he's making money, some places losing money, how we can change this figure. So that's one interesting thing. Also, for example, we can have like a break-even analysis for each one of these grids. For example, in these red squares or grids, the guy needs to increase his yield in over 46%. So there is no technology or agronomic technology out there that makes that. So we can have a clearly this agronomic decision along with like a financial decision. And all of that helps the producers make a better decision and increase his profitability. So just to have an idea, here is the margin, profit margin over time per acre. And this dot line, red dot line on the middle, is when we can predict with high accuracy. So there's two things when you're gonna have your, for example, your revenue, you have the yield and you have the prices. You see over the period, since he planted until the moment that he harvests, the margin decrease. So if he can do a better decision in selling contracts and everything, like when we can predict really well, he's gonna have really good advantage. And we are talking about like $250 per acre. And at the end of the crop season, if he waits to sell on that prices, he's gonna be about 50 or less or $25 per acre, for example. So that has a big effect. So now we move towards the future markets. We can have like different strategies, given if the base is going to weaken, the base is going to strengthen, or if the future prices go up and future prices go down. We have different strategies as the market behaves. So we developed this web app exactly for that, for giving support in all of these decisions. For example, here is the kind of first thing about the web app. In the web app, we have here spot price, futures prices, cotton program, static hedging, cost by the USDA, cost by Texas A&M, worldwide supply and demand. We have forecasting and so on and so forth. So all this information, we bring it together with the agronomic information in yield predictions to make the decisions that we talk about. So I'm going to go forward and say that to build all this system, we use the Ashine web applications with a cloud system architecture. We use Apache Cassandra for data storage and scalability, and GraphQL for API communication and data fetching. So we have all these things behind that. We can incorporate daily data and update all the models and can be interactive for whenever the producers wants to use. So this provide all the information that we need to build our strategies. As I mentioned before, we predict the yield, but also we wanna do like financial strategies. So we forecast basis, we forecast spot prices, we forecast future prices. The web app does it, and we use all these models. And then when you click forecast, they run all these models and select the best one based on the mean absolute scaled error. And then we choose the one that fits the best. So here is one example for forecasting. We have we forecast here like spot prices, and they're gonna have here we're gonna be really interactive. So and then after that we have all the metrics. Okay, we test all of this for this great quality, and that's all our parameters that we can, or parameters no, how we can see the performance of the models and pick the best one and go for it. So also, here is another part about the hedging strategies. We have minimum variance, we have mean variance, and we have how much revenue he's gonna make, what would be the hedge ratio, and so on and so forth. So not only that, we are trying to put everything together. So we also developing a chatbot. And this chatbot has been developed by Caesar, another grad student, and we are incorporate everything in a GPT form. So instead of the guy just go and click and find the information, he can ask Dr. Cotton, and then they provide the answer. They provide the answer to the farmer. So how much time I still have? I'm good. So in conclusion, digital agriculture really helps improve productivity and also help us increase our financial performance as well. We are using these digital twin models that allows us to do yield prediction in season management, but not only that, we can perform a lot of financial strategies. And this web app is really good for us to do outreach. So we can not only develop things at the university, but the producers can adopt this technology as well. So then I'm gonna conclude. I don't know how much more time I have or not, but let me know if this is it or not, or we can jump in questions. How I stop sharing? Stop it? I don't know. Good. Somebody say something.
Okay, you can keep going. You still have some time.
Oh, I still have some time. Just 1 minute. So no, but let me. If I think there's some questions, I'm gonna share my screen again. If I can, wait a minute. I'm gonna open here the app. Just 1 minute. And here is the web app. So I would like to show, for example, here we have all the information like cotton prices nowadays. So we update the cotton prices. It's a kind of interactive. You can choose new years over here as well. So we have throughout the time, we have in season when they are harvesting, when they are not. We have different qualities. We can download the data. We have future prices and everything, as I said. For example, we can choose like forecast. We have forecasts for spot price, future prices, basis, even break even. and we click in, for example, in forecast, and we're gonna have our results. And also the graph is interactive. So the thing is that they are running all the models right now. So whatever information we update, we're gonna have the new information. It looks like they pop up some question here. How often? What's the question?
Yeah. Do you want to
Oh,
start taking questions now?
yeah, people can jump and ask, but I'm just saying, like, is it interactive graph? For example, they end up choosing Arima, and that's it. Yep.
Okay, great. Excellent
Can I stop
presentation.
share? Stop it share? Where I am? Okay. Wait a minute. Yeah, that's it. Wait a minute.
All
Good.
right.
Let's
Thank
go
you
for
so
questions.
much. Thank you so much, Yuri. That was an excellent presentation. There are a lot of interesting questions here too. The first one is from Catherine. Catherine is the executive director of IFAMA. She wants to know what motivated you to develop the app, and also are there other competitors out there providing similar services? Lastly, do you think this could be implemented with smallholder farmers, maybe farmers in Africa? And I think that's related to Srini's question too. Is
Yeah.
it possible to customize this to farmers in Africa?
Well, what motivated us to do this web app? The first thing was academically. We would like to build like financial strategies given our digital twin model, and we had really hard time to collect the data. It's in USDA, but it's not as easy accessible. They provide the data, and you have like 1 week data or so. I don't remember exactly. It was like over 2 years ago that we started this. So we don't have like the time series or everything. So we ask USDA, they share the data, and we provide all the data together in one app for everybody. So that make things easier for us to combine financial strategies with like our digital twin thing. So what must motivate us first was like for us and for some producers, the data were not like available, ready, and easy for the producers. Mainly the small producers that don't buy like any services, right? That somebody that provide this kind of service. But that's what motivate us. So you ask about Africa, right? We are
Yes.
using we are using absolutely we are using USDA data, futures, spot prices all over US that we have. But sure, is Shine app I think is user friendly and easy to do. You guys can develop it, but we need to incorporate Africa data, and I'm not so familiar with the data in Africa. So yes, that I think it's always good if you can put data together to understand better what's going on with the markets. That was our idea. We have road supply and demand. We have a bunch of information that help us make decisions.
Okay, great. Also, is it a free app? Is it accessible to anyone?
Yes, it is. It's we put out there. We are still kind of receiving feedbacks. We are improving it. We are learning a lot about like data visualization if they are user friendly. But it's free, and yes, that's it. It's free.
Okay, great. All right. So, I don't know if if there are any other questions. Okay, also, how often is this platform updated?
Oh,
How often
how
do you,
often?
yeah, how often do
Well,
you update it?
i the prices are updated daily. But when we talk about supply and demand and cost estimates, is depends. For example, supply and demand when the USDA issue, cost overall is once a year. So it depends when the data comes. Yes.
Okay.
So that's it. Yeah.
Okay. D- I know I asked a question about whether there are other competitors. I know there is the ICAC dashboard. How does this differ from the ICAC dashboard?
I think they are more focused on overall economy, and we have something that others don't have. For example, we have forecasting, we have hedged strategies. We don't have a thing just to say, hey, this is the cotton market overall. We have something that's more towards the farmer and the decision that they're gonna do it. I think that's the big difference. We would like to provide information that help farmers make decision, but mainly in our case for our digital twin and that thing, but whoever want to use it can have an idea, you know.
Okay. So, apart from cotton, do you have plans to adapt this technology to other crops?
Oh, yes, we have some other grants, for example, for wheat, for alfalfa, for sorghum. So yes, we are open to expand. But most important nowadays, I think, is how to manage information in the farm, because we have a lot of different technologies, different apps, different strategies. And one good thing is we are trying to combine everything. That's one thing that I think when we look to the future, we need to combine all the data sets and everything so the producer can have one thing in front of them to make decisions. I think that would be the big step forward.
Okay. So you said that this app is able to forecast things like prices with some level of certainty. So can you speak more to that and how that works given the volatility of prices?
Yes. Well, Shine app is based on R. So what happened is we put prices over there every day, and then we have an our R script, let's say, or a program that's going to run all the predictions, all the models that we can have, and they're going to select the best one and bring up the results. So we put down there, that's one thing that we really wanted to do, and we did, is like we provide all the data for people to do download and all the results and what's behind out there as well. So we are doing this forecast, we use this model, that's how the models performance and so on and so forth. And you can be interactive as well. So it basically is in our program. Shine app allows us to is friendly with R, so we can use it for do predictions. That's what I'm saying. Yeah. And then we can provide the specific package. For example, on the paper, we write about which package on R we use to do the forecast as well. Yeah.
Okay, great, great, great. I don't know if there's any other question. I have just one more. And after I do, I'm going to hand it over to Rodrigo to give closing remarks, or hand it over to Catherine. I don't know who's going to be doing that here. But my question is, what are the main challenges in designing a system that integrates both sports and future price data?
Well, one of the main challenges, we have a bunch of data out there, and we need to structure in a way that is friendly to the producer. And producer look at all this information in front of them. For example, the first feedbacks we have is a lot of information. What should I do here to decide something? So it's one of the biggest challenges in make it interactive and provide a quick and reliable answer to the producers. That's the big challenge. Even though we have a bunch of knowledge as economists and we can provide various insights, it's really hard to nail down the one or two insights that the producer really need and gonna make a difference. We need to put that in front of them first. That's, I think, is the biggest challenge.
Okay. Thank you so much, Dr. Khalil. Very interesting topic and very relevant in the times that we live in. So I'm going to hand it over to Rodrigo to continue. Thank you.
Thank you so much. I'd like to thank our colleagues here, Dania, Edoba, and also Yuri, that presented their great research, and it's very interesting to see what you guys are doing. And I really appreciate everybody for being here. As I said in the beginning, all the presentations were recorded, and I'm going to upload them to YouTube, and you can check out those presentations later. And if you have any questions, any interesting insights, you can reach out to our colleagues here to clarify them. Okay. So thank you very much for attendance, and I see you in 3 hours and a half. Thank you.